my name is Lia Maisara binti Abdul Razak with metric number AE200039. I will explain on how to determine the resistance measurement of using Wheatstone bridge. For the activity 1, we can see that the all parameters have already given in table 5.1 of Wheatstone bridge, and we need to set up the value of each element. The value of R1 is 10 kilo ohm, the value of R2 is 2.2 kilo ohm, value of R3 is 30 kilo ohm, and the value of Rx is 5.6 kilo ohm. The value of battery is 10 volt, and lastly, this is the ammeter. And then we need to run the simulation, and we can see that the value of ammeter is far from the zero, so we need to adjust the value of variable resistor, which is R3, until get to the nearest to the zero. We can see that the value of ammeter is 0.41 microampere. Lastly, the value of unknown resistance was already verified using the equation of R2 divided by R1 multiplied with R3, which is 2.2 kilo ohm divided by 10 kilo ohm and multiply with 30 kilo ohm, and then we get 6.6 kilo ohm. Next, we repeat the simulation with the different value of Rx, which is 4.5 kilo ohm, and the value of R3 is 25 kilo ohm. After that, we run the simulation, and we can see that ammeter show the value that far from the zero, so we need to adjust the value of R3 until we get to the nearest zero. As we can see that the ammeter show the value of 0.6 microampere.
Hi and hello everyone. My name is Jashindas Lucky and Kanadas. My matrix number is AE2028. Today I'm going to show you how to determine an unknown resistor using Kelvin double bridge in virtual lab. Let's go. Firstly, in our virtual lab, we set our voltage source to 12 volt and then we switch on the bulb. And then we keep the switch as in short mode. After that, we adjust the rheostat to maintain the ammeter reading set to 2 ampere in the circuit. Let's try some values. 3, 6, yes. And then we record the value of RS in our table. And then we set switch S to open and set low resistance S value to 0.01. And then we set switch S to bridge mode and switch K to open mode. We set the values of R capital A, R capital B, RA and RB from controls box below, or directly adjust the values in the white boxes of respective elements according to the table. Now we set all of the values to 1000. We observe the value on the millivoltmeter pointer. We record the values in our table. Now we set switch K to close mode. By keeping RA capital and RA at 1000, we vary the value of RB capital and RB to get a zero deflection on the millivoltmeter pointer. So let's try for R capital B. Let's see, we put 986.7 and this one is 1004.5. Yes, we get the zero deflection on the millivoltmeter pointer. We record this value in our table. When the zero deflection or null is achieved, we click on calculate on the calculated unknown resistance value box to observe the calculated value of unknown resistance. Our unknown resistance is 0.00995, and then we verify the value of unknown resistance Rx using the given equation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So this is activity 2 for the low resistance. So firstly we set the voltage to 12 volt and then we open this circuit, switch on this board and make sure switch in the short mode, and then we need to adjust the rheostat to make it 2 ampere. So we adjust to the 6, so we get 2 ampere. And then we set the switch to open mode. Then we adjust the resistor. So we choose 0.03. So we choose 0.03 for the low resistor. So next we switch to the bridge and make sure switch get in open mode. So next we need to adjust the RA and RB. So in here we put 300 to all, and we get 0. Then switch K, we switch to close mode. Okay, so we record the others, we record 0 to the table, and right now we need to adjust to the null, below meter point to the null, to 0. So we need to adjust to RB. So right here we adjust to 29.6. Right, and here so the millivoltmeter pointer is to the 0, so we record the value. So after it's achieved null, we calculate the unknown resistance value. So this is our unknown resistance value. So that's all for me. Thank you.